Hello, welcome to the lab of physical systems. Today you are going to explore the torque and the moment of inertia of a solid. You have seen how some simple physical devices can improve the performance of lots of tasks. Today you are going to explore the pulley and the moment of inertia of an object. After seeing Superman stopping the rotational motion of the Earth, you know that it is important to understand how the distribution of mass in an object can affect the motion of that object when you want it to rotate. When you studied the motion of a point particle, you saw that the mass is the magnitude that measures the inertia of the body, how much that object opposes to a change in its motion. The larger the mass, the larger the force you need to apply to induce a specific change in the motion. When it comes to an object which is rotating around a rotational axis, it is not just the mass that matters, but also how the mass is distributed in the object. We will talk about moment of inertia instead of mass as the measure of the rotational inertia of the object. In your task of saving the world from anti-science villains, you want to understand and predict how a cylinder rolls in an incline so that you can use it as a useful and helpful tool. This is the equipment that you have for this lab. It consists of a 3D printed cylinder with spokes and holes in it. You also have some metal rods that fit into the cylinder's hole. By putting the rods in the holes, always keeping symmetry for simplicity, you can have different configurations that keep the mass constant, but they change the mass distribution. To explore how the moment of inertia is affected by the mass distribution, you can put the metal rods in the holes that are closer to the center of the cylinder and then use the cylinder as a pulley. You can hang a thread to the pulley and a mass to the thread. Then you can roll the thread around the pulley and drop the mass. You can measure the acceleration of the hanging mass. Acceleration will be constant all through the fall. Think how you are going to measure the acceleration. Because in its descent, the falling object makes the cylinder rotate. The moment of inertia of the cylinder will affect the acceleration of the falling mass. So somehow you can measure the moment of inertia by studying the motion of the falling mass. Once you have done this, think what would happen if you change the position of the rods in the cylinder from the closest to the center to step by step going to the farther from the center. Let's relate the moment of inertia with the acceleration of the falling mass. We don't know the moment of inertia of the cylinder plus rods system, but we can use a Steiner's theorem to write it in terms of the moment of inertia of the cylinder, which we may call I naught, and the moment of inertia of the rods. From Steiner's theorem, we know that the moment of inertia of this cylinder rotating around this axis is the same as this cylinder, the same cylinder rotating around this axis, but here, plus m1 r1 square. In order to get the total moment of inertia, you know that that total moment of inertia is going to be equal to the moment of inertia of the cylinder plus 8 times the moment of inertia of each one of those rods. You should solve Newton's second law and the equation of the torque to find a relationship between the time that the mass takes to hit the floor and the distance where you're putting the rods from the center of the cylinder. And you should find an expression like this one, where this is the distance of the rod to the center of the cylinder, this is the time that the mass needs to hit the floor. These two constants, A and B, will contain the parameters that you've been measuring, like, for example, the masses, the distances, and also gravity, G, and the moment of inertia of the cylinder. So that's why you should think about how to use this expression to calculate the moment of inertia of the cylinder and also G. Now that you understand how the mass distribution affects the moment of inertia of an object, let's study the motion of a cylinder descending an incline, rolling without sliding. When the cylinder rolls on an incline, there are three forces acting on it: the weight, the normal, and friction. Weight acts on the center of mass, while the normal force and friction act at the contact point between the cylinder and the incline. Remember that the normal force is perpendicular to the surface and friction opposes to the motion. Can you think of which force or forces induce the rotation of the cylinder? Without doing any calculations, which configuration do you expect to descend the fastest? Which is the slowest? Why? You can again solve Newton's second law and the equation of the torque now for the cylinder descending down the incline. You should be able to predict the time that the cylinder will take to arrive to the end, to the finish line in incline. Now, let's go to the racings. To wrap up, think of what you have learned in this lab and which conclusions you have arrived at. Then write a brief communication stating these conclusions. Select one main take-home message and consider it for the title of your brief scientific communications. Write down everything you do and may the science be with you.